So let us continue with the canonical transformation. Consider this Hamiltonian of the harmonic oscillator, which is q squared over 2 plus p squared over 2. Let us focus on this transformation first. Q equal p capital and p small equal q capital. Okay, this simple transformation will turn out to be non-canonical. Okay, let's see how using maximum. So as you could see, I have written here the Hamiltonian in terms of q small and p small, and the original differential equations, which are the Hamilton equation. Q dot is equal, which is derivative of q small with respect to time, is equal to partial h by partial p, and p dot is negative partial h by partial q. I am putting this single quotation just to prevent Maxima from executing the derivative at the left hand side, because if he executes the derivative, he will write partial q by partial t is equal to 0. This is just a technical issue related to this symbolic manipulator. Our suggested transformation is that we remove q small and substitute it by p capital, and remove p small and substitute by q capital. Okay. The new Hamiltonian is obtained by substituting this transformation into the old Hamiltonian. Okay. Now, before trying to use this new Hamiltonian h dash to get q capital dot and p dot, let us first identify the correct equations for p dot and q dot. Okay. The correct equations for q dot and p dot are obtained from the correct equation for q small dot and p small dot. That's why I'm requesting here to substitute the transformation into the q dot equation and transformation into the p dot equation. So what do we get? As written here, these are the original equation from the Hamiltonian, and this is the suggested transformation, and this is the new Hamiltonian, and these are the correct equation. For example, if we remove q small and write it p capital and p small and q capital, we will get this. And the same here, remove p small and q capital, and the same. These are the correct equations. Okay. Suppose now that you try to get these both equations from this Hamiltonian. Okay. For example, try to get partial h by partial p capital. Partial h by partial p capital will be equal to simply p. Okay, p. This is, however, yeah, you will get this kind of equation. For Hamilton's equation, it will tell you if you believe again that partial h dash by partial p is equal to q, will get an incorrect result, because dq by dt is not p, it is negative p. Again, if you try to get p dot by negative partial h by partial q, as is written here, okay, you will get also an incorrect answer, because dp by dt is not negative q, it is q. I hope now you understand. Again, and please have a look at the another example. For the second example, q small is equal to negative p and p small is equal to positive q. Both equations, the correct one and the one derived from h dash, will be the same. Okay, you can find the details here in this Maxima file. Fine. So what? So you may understand now the meaning, at least, of the canonical transformation, and you may be able to verify on your own whether the transformation is canonical or not. However, the method used for verification is a little bit confusing, because you need to derive the differential equation twice and see whether it is correct or not. So the question is whether there is a simple test to know whether the transformation is canonical or not. The answer is yes. Okay, the transformation will be canonical if Poisson bracket is preserved. That's why we needed to clarify or explain Poisson bracket before getting into a canonical transformation. Okay, so the Poisson bracket, or the transformation that preserves the Poisson bracket, will be a canonical. What's the meaning of preserve the Poisson bracket? If q capital p capital equal to 1, and if q Poisson bracket is and p Poisson bracket is equal to 0. Please remember that q capital and p capital are functions in q small and p small. Okay. you can apply this to the example of q small equal p capital and p small equal q capital. You will find that qp is not equal to 1 but is equal to negative 1. Of course, this could have saved us much confusion. The proof is provided in the next slide. It's a little bit complicated. We start with dq capital by dt. It's equal, since q capital is a function in q small and p small, so using the chain rule, we get q dot equal q capital dot by partial q dot, q capital by partial q capital by partial pp dot. Remember from Hamilton's equation that q dot is equal to partial h by partial p, and p dot is equal to negative partial h by partial q. Fine. Now please return back to the h dash, the new Hamiltonian. Remember that q capital is and p capital are in fact, the new Hamiltonian is obtained from the old Hamiltonian by replacing q small and p small by q capital and p capital. Hence you can get, for example, partial h dash by partial q, which will be partial h dash by partial q capital by partial q small, and so on. And you could also get partial h capital by partial p. Please remember that h dash and h are the same quantity. It means the following. It means that you can replace this red one here, partial h by partial q, by this one, partial h dash by partial q. And you can replace partial h by partial p here by partial h dash by partial p. Okay. Again, return back to q dot. This was q dot. Okay. We are writing partial q capital by partial q again, and partial h by partial p. It is partial h dash by partial p, as you could see. So we are just repeating this term here in the second line, here in the third line. And for partial q capital by partial p, it is repeated. Okay. Again with a negative sign again, but for partial h by partial q, instead I am writing partial h dash by partial q. So this one here in the second line is repeated here in the fourth line. So what? You will find that this yellow expressions will cancel out together, because you are having here q capital q small, q capital q small, h dash q capital, h dash q capital, q capital p small. They are essentially the same term but with negative sign, so they cancel out, and we are left with partial q capital by partial with this one and this one. Okay. And also, if you focus, you can conclude that partial h dash by partial p can be taken out as a common factor. Okay. And you get this one. What is this? This is the Poisson brackets of q and p. So for q capital dot to be equal to partial h dash by partial p, we need this one to be equal to 1, or the Poisson bracket to preserve its structure. Okay. So we have proved for q dot. For the next slide, you have the same proof for p dot, and it's following the same line. You can read it on your own and verify that everything is as expected. There is an important example for the harmonic oscillator adopting this canonical transformation. Okay. You can see what will happen for this canonical transformation. Okay. I'm opening this Maxima file. This, as you could see, this is yes, this is the canonical. This is the transformation. You can verify whether it is canonical or not. And the most important is that now, since it is canonical, you can get the equation in terms of the new variables. When you use this transformation and do the simplifications, you will find that h, the new Hamiltonian h dash, will be in terms of p capital over 2 pi, which is very, very simple, without any squared and so on. So the new equation, which is dq by dt, will be equal to 1 over 2 pi. Hence q capital, the solution for q capital, will be equal to 1 over 2 pi multiplied time. And since dp by dt is equal to 0, hence the p capital is conserved. P capital is conserved means simply what? Means simply that anyhow the mathematics is so much simplified in terms of q capital and p capital. Okay. Hence people can get the solution easily. without getting into much mathematical details. Okay.